All right, so here we are at number 16 and 17, and we are factoring the trinomial completely. And with each of these, we're going to be asking ourselves that set of questions that we should be asking at every single factoring problem. Is there a GCF, and then how many terms are there? All right, well, let's take a look at 16 here, and we'll go ahead and rewrite it out here so we have some more room to work with. And we have z squared plus 3z plus 2. All right, so question 1, is there a GCF? I don't think so. So we can move on to question 2. How many terms are there in this expression? And we have 1, 2, 3, right? Hence a trinomial. And when we're factoring a trinomial, you have a couple different methods to use. You can either use the scissors method or trial and error or the AC method. I'm sure there are a couple other methods. But I will primarily be using, like I said in the introduction, the scissors method. I think it's the most accurate and the fastest way. But if you are comfortable with another method, then by all means use that method. Or if your professor has dictated that you use a specific method, then certainly use the method that your professor has asked you to use. But let's take a look here. So we have z squared plus 3z plus 2. And actually with 16 and 17, these aren't too bad because whenever the coefficient in front of your squared term, or variable rather, is 1, which it is here, right? It's kind of that invisible 1. These really become easier the more you do, and you'll be able to, I promise you, the more of these you do, if you go through your homework, go through this practice test, you will be able to start doing these really even in your head. Because all we're going to do with a trinomial that has a 1 as the coefficient in front of your squared term is ask yourself, all right, we're looking for factors of 2 that add to give us a positive 3. So right away, we know that a trinomial is going to factor into a binomial, right? So I always go ahead and I just create 2 sets of parentheses that are empty. And I see that we're working with a z, so I always fill in whatever variable letter I'm working with. And then I say to myself, all right, factors of 2 that add to give me positive 3. Well, the factors of 2, if we want to list them, are just 1 and 2. So we know that we're going to be using 1 and 2 in our set of parentheses as factors, but now we just need to make sure that our signs are correct. So we want 1 and 2 to add up to positive 3. Well, if we want them to add to positive 3, they both need to be positive, right? Because positive 1 plus positive 2 gives us that positive 3, and positive 1 times positive 2 multiply together to give us positive 2. So we know that these are correct. All right, let's take a look at 17. So we have k squared minus 14k plus 48. Again, this is a trinomial. The coefficient in front of our squared term is 1. So I'm going to go ahead and create the set of blank parentheses. We're working with a k, so let's go ahead and fill in that k. And now we're looking for factors of 48 that add to give us negative 14. Well, let's see if we can list the factors of 48 here. Well, we have 1 and 48. We have 2 and 24. How about we have now 4 and 12? And 5 doesn't work. We have 6 and 8. And I think that might be it. All right, so let's go ahead and take a look at these factors here and see if any of these factors can add to negative 14. Well, can we get a 14 from a 1 and a 48? No. Can we add a 2 and a 24 together in some combination to get negative 14? No, I don't think so. Well, can we add in some combination a 4 and a 12 to get a negative 14? No, I don't think so. But look here, we have a 6 and an 8. Can we add in some combination a 6 and an 8 to get a negative 14? Well, sure we can. We can take negative 6 plus negative 8, and that'll give us negative 14, won't it? Now normally we don't do plus minus like this. We would just say negative 6 minus 8 gives us negative 14, but we really are adding here, aren't we? So we know that we're going to have a 6 and an 8, and as we just saw, the sign for each is going to be negative. And let's double check this. Well, negative 6 plus negative 8 does in fact give us negative 14, and negative 6 times negative 8 does in fact give us a positive 48. So we know that this set of factors works as well. And just like we were doing when we were factoring by grouping, you can go ahead and take your factors and multiply them out, FOIL them out, and you should get back to what you originally started with. So let's try that. K times k is going to give us k squared. K times negative 6 will give us negative 6k. Negative 8 times k will give us negative 8k. And negative 8 times negative 8 will give us positive 48. Let's go ahead and combine like terms. So we get k squared minus 14k plus 48. Does this match this? Yes, it does. So we know that these two factors that we found were correct.